welcome to our talk. We're here to talk about telemetry at scale. And we want to leave you with a few blueprints to consider when it comes to observability. How many of you have instrumented observability within your organization today?
Okay.
Oh, for the ones that haven't, we need to chat afterwards. All right, so we'll get started. My name is Marino Wijay. I am a staff solutions architect at a company called Kong. So I work with end users to help them onboard APIs into modern platforms. And when it comes to APIs, you probably have heard of an API gateway. You've probably worked with a service mesh before, might even work with a developer portal of sorts. And that's the full gamut of understanding how we do API lifecycle management. If you want to follow along, scan that QR code so that you don't have to, extra zoom in, if you will, or use a magnifying glass. And you have access to the deck, so feel free to share with your colleagues or any of your peers. But we're here to really dive into some of the observability details, and I'm going to pass it over to my co-speaker.
Yeah, so hello everyone, I'm Aakansha, and I work as a solution architect for this company called -0. So we are an OTel native observability platform. So every day I'm talking to the customers and helping them onboard on their OTel journey. I'm also very active in the CNCF community, and I'm a CNCF ambassador, just like Marino. And yeah, so I really look forward to KubeCons, and this one is extra special for me because this is my first time speaking at KubeCon US event, and it's a pleasure to be speaking with Marino. So yeah, I think we are good to start. So let's talk about OpenTelemetry in a nutshell. So I would say that it's it's an open standard, and it helps you define a consistent standardization to know how to collect your telemetry. It gives you the data model, it gives you the API specification, the semantic conventions, and tells you how your telemetry should ideally look like. And you have the language libraries which implements on those ideas. So OTel basically tells you that, hey, these are the same rules that we're gonna follow everywhere. And that's why I love these open standards, because it's consistent all across. Also, it's not a very small project. It's the second largest project in the CNCF ecosystem, just right after Kubernetes. So you can imagine that this is a widely adopted project, and organizations are considering it, and community members are really active and doing a lot of development. So if you follow along, and you can join these Slack channels, and you can join these weekly meetings, so you will see that it's being regularly updated with new features and everything. It's really active. Also, you would often hear people say that it's a very cool project, and because it really implies that this is the standardization, it lays the foundation, and now our organizations are really moving towards the OTel journey. So we talked about what OTel is, but it is also important to talk about what OTel isn't, because there is a lot of misconceptions and confusion regarding it. So it is not proprietary, it is not owned by any company, it is really truly open source, and people are really actively maintaining it, right? It is also not a query language, it does not have a storage or a backend, so you cannot just log into OpenTelemetry and say that, hey, I want to visualize my trace, because it cannot store that data. You just have to collect it. So basically, it collects it, it processes it, and sends it to the backend. It could be any telemetry backend. Also, people say that OTel is not complete, there is a feature incompletion, right? But think from a different perspective. No project is complete, right? And this is where people are actively working on what else should be included. We take feedbacks, and there are many new features which are coming in. Now let's see where does OTel fit into the complete picture. And this is a very high-level overview of it. So if you, on the left-hand side, you can see the microservices, and you have two ways of instrumentation. It could be manual, you are doing some code changes, and then you're manually instrumenting and collecting your telemetry, or it could be auto-instrumentation. And then you have your shared infrastructure, which could be on Kubernetes, any cloud providers, Vercel, etc. Then comes the middle layer, which is the OTel collector, or you could also say it as a data collecting agent. So all your telemetry from these applications which you have instrumented are now collected here, and then it collects it, it processes it, you can transform your data, and then you can enrich it if you want, and then it really sends it to any telemetry backend. It could be a time series database, it could be any OTel vendor, right? So this is the beauty of OTel, because this is like an open standard. You just have to instrument it once, and you can send it anywhere. If you want to just send it to as many backends as you want, you can. So this is why I love the OTel so much, right? Now we talked about collector, and there are different deployment patterns. So let's talk with the very simplest one, which is having no collector at all. So you will just directly instrument your application with an OTel SDK, and then it will collect the telemetry, and you can directly send it to the backend. The problem with this simplicity is that it is a very tightly coupled with your backend, and it restricts you when you are trying to scale your infrastructure. It takes away your flexibility. So we introduced the agent way, and so for example, you have multiple applications. There are different OTel SDKs you are trying to instrument it, and then you can send it to the collector, which is the mid layer in it, and then that collector will send it to the telemetry backend. Of course, there are different ways that you can have the collector as a daemon set, or you can have it as a sidecar collector. It really depends on how your environment is like, what scale you want to get into, what are your business needs. So these factors are really important when you're considering your deployment patterns when you are doing all these instrumentations. And finally, we have the benefits of OpenTelemetry. So now you would have figured out that, hey, this is a vendor-neutral project, right? And it is the standardization across all the telemetry signals, be it the traces, metrics, logs. Also, it has a strong ecosystem, well-documented, proven. It's very mature. Organizations are using it, adopting it, and doing it on large scales. And also, as an unlocking factor, which makes it so much better, because it has the auto-instrumentation support as well for a lot of languages. So it makes the barrier so much lower, because you can have the agent right into your clusters, and it can automatically just collect your telemetry. And then, of course, if you are hiring for SREs, developers, it's just like a very common technology, because everybody knows what OpenTelemetry is. And finally, I would say, I will summarize it as like a line that this is the last observability agent you would need, because you just have to instrument your application once, and then you are good to go.
So when we're thinking about the complexity of how observability could be, there are various endpoints and telemetry pieces that we have to consider. So you have to think about your infrastructure for a second. You might have deployed your workloads into a cloud environment, or you might be locally hosting your workloads in your own on-premises environment. You might be using Kubernetes. How many of you are using Kubernetes today? I mean, you're here at KubeCon, right? Okay. So within Kubernetes, I mean, there are a lot of different telemetry bits and data available to us, except there's no way to correlate all of this information. And then you start deploying applications, you start deploying pods and microservices, and then you start to think, okay, maybe I also need to layer in some additional security pieces as well, or better routing, if you will. And so you'll probably think about using something like an API gateway and ingress, and then you might even consider using something like a service mesh. Now, all of these additional tools need to be monitored themselves in addition to your application stack. So for example, you've deployed a service mesh. You have to watch the control plane. You have to watch your sidecars. And then on top of that, you have to watch the health of your cluster where your services are running. And then you actually have to watch the services themselves and understand how they're sending data, what they're sending, how they're performing, and whether or not they're actually having higher latency or bottlenecking somewhere along the lines of how they're performing. So there's also an element of logging too. When something goes wrong, normally you'll look at your log systems and then try to understand and make sense of what might be going wrong with an application, like let's say an exit code 0 and why that system failed or that process failed. So there's an intersection where end users need something like OpenTelemetry. There's always going to be a need for that level of observability where you're considering things like traces, metrics, and logs. And everyone's worked with logs. Everyone has a good concept of metrics as well. But tracing is actually a very important piece of this entire conversation. Because if you think about a trace for a second, a trace is comprised of multiple spans. And in each one of those spans, there's something called an X header ID or a B3 header. And what that does is it actually links each one of those spans together to form a trace so that you can see something end to end. Now, why would this be important to us? Let's just say you've deployed a multi-microservice application to Kubernetes, and it's running very well, and all of a sudden, on Friday, you start to realize that the application is just not responding as quickly as you expect it to. Where do you start to look for the issue? Where do you begin to understand where that issue is or where it lies? And so something like tracing can actually pinpoint that issue a little bit better because it can tell you if a particular service or a particular microservice in that request path has significantly higher latency. That might be indicative of the fact that maybe the service itself is running out of CPU and memory resources to process requests. And that might require you to consider, maybe I need to scale this up or scale up the actual service inside of Kubernetes or whatever workload environment that you're thinking about. Now, when you're actually thinking about the overall elements of telemetry, you're also considering how this better aligns to your SLAs, your SLIs, and your SLOs. And this helps you make sure that you achieve better uptime within your organization for an application or several applications. And then when you also think about all those logs that you have to put somewhere, and you're trying to understand and make sense of what these logs are telling you. Because look, you'll read a log and it'll tell you a whole bunch of information with timestamps and random messages, either errors or infos or debug info information. And it's hard to make sense of it all. So having that log information derived from something like OpenTelemetry means that we get to take advantage of things like agents that effectively can read that information faster than we could and tell us where the problem is. This is very much like if you've ever worked with Wireshark before and used technologies like traceroute, you'll begin to understand that tracing is just the same thing except at a higher level. And if you've ever looked at a Wireshark dump, there's just a lot of information there. There are tools today that help you decipher what's going on within those Wireshark dumps. The same thing applies to logs and tracing information as well as your metrics. Now, there's a couple of OpenTelemetry deployment patterns that I just want to share with you. The first pattern, which is something that I've encountered within an end user organization, is after they've decided they wanted to standardize on something like OpenTelemetry, they've decided, okay, let's just stick OpenTelemetry collector sidecars everywhere. So they run as sidecars inside of your pod alongside your application container. Now, this limits the blast radius significantly because if a service fails, that single collector fails. But the other side to this too is you now have to consider that there is so much more CPU and memory you have to allocate to each one of these collectors, and then you have to individually manage them. Secondly, when you're also thinking about how you deploy these collectors, some collectors might have certain sets of configurations while others might have different configurations. They might be going to different telemetry backends or endpoints. Some might be going to -0, or you might be migrating from, like, let's say, Dynatrace or New Relic to -0. And so you need to be able to lifecycle different collector configurations so that you don't lose any of that telemetry data. Now, this isn't an ideal pattern because there's just so many more extra collector containers you have to manage, but it's a good start. Now, here's a much more consumable approach where Kubernetes is the healer. If something goes wrong with your collector, Kubernetes will come to the rescue and make sure that it reconciles how that collector should operate. Now, normally what we aim to do is run collectors as a daemon set. So if you've got a multi-node cluster, each node in your cluster is going to get a collector. And so if that node fails, your workloads get restarted, obviously, in another available node in that cluster pool or that node pool. But this also means that you're not having to consume additional levels of CPU and memory. You're centralizing your configurations a little bit more, and there's less components to think about and manage. Now, there might be some exceptions and outliers where, let's say you have an API gateway that runs as a data plane, and there's some telemetry that needs to leave it to go to your telemetry backend. You might stick a collector there, but if you're running something like a service mesh, your sidecars are the ones that are collecting all of that telemetry data and sending it up to a daemon set level collector, which then in turn will condition that data and then proxy it up to your endpoint, whatever it might be. Now, overall, this just reduces the failure domain, so it becomes a lot more easier to manage. You don't have to think about heavy scale issues. You don't have to think about memory consumption or allocating a set of memory and CPU to each one of those collectors. If it was a sidecar, it just runs as a daemon set. Now, when we think about scale, we also have to think about how we handle very, very large environments, and Aakansha will tell you a little bit about how OpAMP works.
So just like a quick raise of hands, is anyone aware of what OpAMP is? Okay, there are a couple of people. Nice. So when we're talking about scaling your telemetry, you will have many data collecting agents as well. So OpAMP is vendor agnostic. It doesn't really care which vendor it is from. And an OTel collector could be an agent as well, right? So OpAMP stands for like a network protocol, which basically allows you to remotely manage all your data collecting agents. So just imagine that if you are like scaling your telemetry, it will be hard to manually configure all your agents. You would like to have a situation where you could just have a control server where it can just see that what is happening in my agents. If I would like to have that ability to remotely configure it, and maybe something just goes wrong in the configuration. Maybe there is a drift in the version, or the agents are like out of sync and there is like no heartbeats coming in from the agents. So OpAMP protocol gives you that ability to remotely do that and like make all that configuration just so much better.
Okay, so we're going to summarize with a few key blueprints that you should consider. And when you're starting off with something like OpenTelemetry, the fastest way to realize that observability power is to instrument with SDKs. So you might be writing your backend, and in your backend, you can actually call on an SDK that uses the OTLP protocol to effectively send telemetry data either to a collector or even to your backend directly. Normally, a collector is much preferred because that way you don't have to think about sending all different data. So you have to think about bandwidth for a second, right? We don't have infinite bandwidth in the world or within your organization. And you also have to think about how much you can send up to an endpoint. But if you force everything to go through a collector, it'll proxy everything up, remove all the unnecessary information and data, condition that data so that the actual telemetry backend, the platform, the dashboarding that you're using actually just shows you what is relevant to you and to the workloads and to how your actual workloads are performing. You also have to think about that trace propagation as well. Now, when you have propagation enabled, that means that you can actually track all of your different service calls and how they communicate with other services. So let's be real. We're never just going to go to a stub service and then get a response. We'll go to a front-end service, then to a back-end, which goes to another back-end, which goes to another back-end, which you get the point. But in that propagation, we want to be able to identify where something might be going wrong to better pinpoint and better scale an application back-end or a microservice back-end. We also might want to consider if we need to optimize it or refactor it in some way or even rewrite the code because it's just not optimal overall. The idea is to really just give you an initial start by using OpenTelemetry, but the reality is you also want to decouple that telemetry bit from your applications and put that somewhere else where platform teams would take advantage of it and be able to engineer for it as well. So for example, if I was using something like Kong Gateway and Kong Mesh, they have the ability to take in that telemetry data on behalf of your applications and then export it via OTLP as well. So it'll send it using that OpenTelemetry protocol to a collector. That collector will proxy it up to your endpoint as well. And this allows you to then consider if you've already got instrumentation happening within your code, and then you've also got sidecars that are sending telemetry data, you actually achieve better correlation of how your application goes to your sidecar, and then your sidecar goes to the actual OpenTelemetry collector. Now, like I mentioned previously, we would deploy OpenTelemetry collectors as daemon sets. And this just allows for much better context around how our applications are performing. We can also condition the data before we even send it up, like I mentioned previously. And it just enriches the way you view the telemetry of different microservices. Because when you're thinking about reducing your MTTR within an organization, and you're trying to limit the number of outages that you have within your organization, or you're trying to limit downtime, that telemetry data becomes extremely important. And granular telemetry data becomes even much more important too. That's only something you can achieve with OpenTelemetry. And then when you get to that level of scale, like Aakansha mentioned what OpAMP is doing and how it's performing and how it solves the scale problem. We're thinking about an agent, an OpAMP agent that lives alongside your collector. And it's actually watching the collector because it's loading in configurations into that collector. But where does it source it from? From a supervisor that sources it from a backend server. So let's just say you've got a set of collectors already deployed, already running, already passing telemetry data. And then you decide, like I said, you have to migrate to a new backend system. Or you like to adjust the window sizes of your traces because you're ingesting too much. Or you're trying to adjust how much metrics you're capturing. So instead of just doing a complete swap and then losing some of that telemetry data, you can roll this out in a hot reload sense where you load in dynamically a brand new collector configuration without actually losing any form of telemetry data whatsoever. And that's an artifact of how the OpAMP protocol works alongside with agents and supervisors and that server backend. Now, some of you might be wondering, like, why wouldn't I use the GitOps approach to updating my collectors? Understandable, I get it. I've actually encountered the same question. And how I'm actually addressing this is when you actually have a massive enterprise, sometimes GitOps doesn't fit, it's not a one-size-fits-all approach. And so you have to think about out-of-band management of your OpenTelemetry environments and your OpenTelemetry observability. And if you pair that alongside your GitOps, it becomes a lot more challenging to manage your telemetry data as well, especially if you are running a new pipeline, because there's a change detected in your version control system. That means there is a risk that you lose some telemetry data as well. Now, these are 3 blueprints that I want you to consider. If you're getting started, you absolutely can start with your SDKs. But if you're a little bit more advanced, you are running something like Kubernetes alongside service mesh and maybe ingress technologies, then you've got the collectors you can play with. And then when you're ready for the enterprise level scale, that's where OpAMP comes into the mix. And our buddy over there, Adnan, definitely can tell you a lot more about OpAMP if you're interested. I know he's just like kind of covering his face now because he didn't want the attention, but I saw him taking pictures, so I'll call him out. But that's it for our session. If you have many more questions, we'll open up for questions as well. But we'd like you to rate our session as well. Tell us how we did, give us some feedback, tell us how we can improve it. If you were looking for any additional detail, we'd love to hear about it because we'd love to deliver version 2 of this session. And finally, if you are looking to find out more either about API gateways or service meshes and how you can implement them in your own environment, I'm at booth 221 all afternoon. And
you can find me at booth number 710. So And I'm, of course, available to talk about anything OTel and observability. Also, again, resharing the slide deck here. So again, if you would like to have this resource, our slides, you can scan it and have it. And yeah, so any questions, we will be happy to answer them.
Yes, if you want to ask a question, there's a mic right here so that everyone can listen in.
How are you correlating app SDK metrics with mesh level?
So in order to correlate app level SDK metrics and as well as mesh level metrics and even tracing information, it really comes down to a few things, right? A labeling mechanism, if you will. So on the collector side, if you use labeling, what you can do is actually link what you see on the app SDK side as well as what you see on the service mesh side. And what that enables you to do is when you look at, let's say, a -0 dashboard, you're now seeing that full propagation or that full context end to end. So it actually comes down to how you've configured your collector, and that labeling mechanism is what creates that linkage.
Can you give an example?
I can show you actually later on. If you want to come by the booth, we can talk a little bit more about it.
Okay.
Because I don't have it right now, but yeah.
Thank you.
No problem.